a proof toolbox. Okay? We're going to start working on this so we have some tools in place. So when we attack a proof, first of all, do we have a tool that we already know about that we can use? If not, that's a good time to ask a question or do some research. In the real world, you probably have to do research. In this class, you might be able to ask your friend, you might be able to ask me, you might be able to just look through your book or your notes. So that's what we're going to work on. So I'm going to just call it a toolbox. What did I do? That's supposed to erase when I hit that. There we go. All right, so I'm going to write basically up here toolbox, and we're going to start with what we know. All right, proof toolbox. That got awkward real quick. All right, the first thing that we're going to, in our toolbox, is we're going to have definitions. Okay, let's think about the definitions we've used so far in our proofs. Okay, and then I'm going to write them all down here. And then we can have this, and then we can use this kind of as kind of a cheat sheet, but it's really just all the tools you know how to use. Okay. All right, let's see here. I think one of our first things that we've used is midpoint. Okay, what does midpoint give us? Midpoint gives us two congruent segments. Is that true? Okay, so anytime we see midpoint, we're going to use the definition of the midpoint to give us two congruent segments. Okay, here's our next definition. Segment. You actually haven't seen this one yet, but you will. Bisector. Segment bisector. It's going to give us two congruent segments. And if you remember, the definition of bisector is it's like a ray or a line or a point that cuts a line in half or goes through its midpoint. So basically, segment, bisector, and midpoint do the same thing. But when we give our reason, we're going to do definition of midpoint if they give us a midpoint, or definition of segment bisector if they use the word bisector. And the last one is that we have so far probably, angle bisector. Okay, and so that's going to give us two congruent angles. Okay, so we might add some more definitions throughout this chapter, but this is a good start. You see these words. Okay. So I'm going to kind of go to a hybrid. The next thing that we are going to be given potentially, and you might want to leave some room so we can add some definitions. Or we might just start over, it just depends. Depends what you want to do there. So the next thing that we're going to look at is basically this symbol or the word parallel lines. Okay, if we see parallel lines or that symbol, things are parallel, what's that going to give us? Well, it's going to probably, even though it's dealing with lines, everything we learned about parallel lines had to do with not lines, but had to do with what? Had to do with angles, right? So this is going to give us two congruent angles. And so far what we've seen is the fact that I'm off the screen. is alternate interior angles theorem. All right. Could we potentially use consecutive interior angle theorem somehow, or alternate exterior angle theorem somehow? Maybe. Those are all in play, but so far we've seen alternate interior angles, and it works really well with triangles because we're dealing with angles inside the triangles, so that makes sense. So it could be all of them, but for now, this is what we've seen. And so I want to focus on these first before I do research, right? Okay? And this is, we've only done how many proofs? 6? 6 proofs so far? I did 2 in notes, and then you just did 4. So there could be more. Now I'm going to start drawing shapes. Okay? If you see a shape like this, or maybe it's, since we're doing triangles, it's not going to look like that. Maybe it looks like this. Probably what that's going to give us, again, 2 congruent angles. And what rule are we going to apply here? Vertical angle theorem. Okay. And that's not even, you don't even have to read to be able to do that. You just need to look at the shape, and if you see this, I'm going to automatically think it's going to give me 2 angles. And there's only so many ways you can make an X with triangles. We just saw one where they had the X with the triangle, but then they put made it into a square, right? Or a rectangle. We just saw one that looked like, you don't have to do this part. Or maybe the Scottish flag. I don't know. Is that what the Scottish flag looks like? Isn't it like blue with... Never mind. You need to learn your flags, right? Flagology. Do you do that in Oklahoma history, learn the Scottish flag? No. No, that's probably not applicable to Oklahoma history. Or is it? Nope. Go ask your Oklahoma history teacher, see if that's applicable. Okay. All right. Let's see here. There's another shape that we're going to see commonly. If we see this shape, we're going to get 2 congruent sides. And we're going to use, what property is this? Reflexive. Right? So just by looking at the shape, you're going to get basically a free angle over here or a free side over here by using these theorem or property. Okay, have we seen anything else? Okay, we haven't seen anything else yet? All right, well that's fine. So I would maybe do a different page or leave some room. And so here's going to be ending problems. This is ends. Okay. We know how to end with SAS. That's all we've learned so far, right? So I'm going to put end tools, right? So what we're going to add today is SSS. What do we think SSS is going to stand for? Side, 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 okay? None of these names are very creative, are they? They're trying to communicate with the least amount of letters what we're doing. So that's what we're going to go into. So I'm going to close the tools out. I'll close the tools out and I'll restart a new video for the what we're doing.